We'll spend some amount of time here. As I said, we'll cover explain. So we'll spend good amount of time here because this is important. So there's the explain method, which many of you have shown. It prints the physical plan and of course logical and optimized logical plan for debugging purposes. Few things you can check. What you can check here is predicate push down. So we'll see pushed filters. There's a flag, and I'll have an example of that. I will show you pushed filters in the plan. If you're querying from a database and you're specifying a where condition, then preferably you want this pushed filter or in the, which means a predicate push down to be true, because you want the where condition to be evaluated at the database server itself, not after fetching all the data in the Spark and then you do the filter. It's unnecessary, will cause a lot of network IO, and also it will be slow. So if you see this as a false, then all the data will travel over the network and filtering etc. will happen at the Spark level, which will make it slow. How to add shuffle? I think in one of the assignment I had given, someone was asking, Rajesh I think was asking about the shuffle and all. So I will show you, the plan will show that if shuffle is happening and or not. If you see if shuffle is happening, you figure out a way how to avoid it. So you will see in the plan, if you see some exchange, that means shuffle is happening. Now what you have to, I think I have, do I have the flow? No, I don't. I have in some other way, but what Spark does is when you submit the code, it will create a logical plan for your code. That logical plan will get converted into optimized logical plan. So once logical plan converts into optimized logical plan, that means some optimizer has run over this. Then optimized logical plan gets converted into physical plan, and physical plan is the one which gets executed. The physical plan, so you can see this in the UI also. I have a separate section for UI. We'll walk over that in detail, but I here just giving a hint that you can see the physical plan over the Spark UI. And Spark UI is a very powerful thing. A lot of information you can see from Spark UI. And I'll explain, I know there's a Spark also has documentation of the Spark UI, but I will also explain. And this is the way you go to SQL tab, and there'll be graph and there'll be the details or something. You should be able to see that there. What we see is explain. If there are many variations of explain, one of the variation of explain is you pass true flag. It means extended is equal to true or false. If you pass true, then it will print the logical plan, optimized logical plan, physical plan, all it will print, and it will automatically print on the console. You use it for debugging purposes. Since Spark 3, there is another explain method which takes string. Here it is taking a boolean. Here you can pass a string. What you can pass in the string, you can pass as one of these: simple, extended, code gen, cost, or formatted. So we'll go into each of these examples. So let's say this is I copied from internet from somewhere. So let's say this is just to mimic the situations where we can see at least proper plan. So what I do is I create a or whosoever I copied from. So it creates a data set or data frame from 1 to, I think, whatever number of digits are there. There are other data frame from 1 to these digits with 2 partitions. Then data set 1 is getting repartitioned into 7 partitions. This data set 2 is getting repartitioned into 9 partitions. Then data set 3 is doing select action ID multiplied by 5 as ID. So it multiplies this this DS3, which is repartitioned to 7 partitions and as ID. Then it joins data set 5, which is the latest one, with data set 4, which is this data set based on the ID. Then over this joint data set, it says select expression sum of IDs, and then it explains. So this, once you run this and you say explain, once you code this and say explain, this is what you get, what you print. Now I'll go into many of this one by one. So you see exchange happening here, exchange happening here. Exchange means shuffle, and you see one exchange is round robin partitioning, second exchange is hash partitioning, and then some sort of short happening, then some sort of hash aggregate happening, and all sort of things are happening. So I will go into each of these. This is when you so this is just normal when you say sum.explain. When you say explain.true, you will see a lot of past logical plan is this, analyze logical plan is this, optimize logical plan is this, physical plan is this. We are more or less concerned about physical plan. Why would you want to look at the logical plan, analyze logical plan, optimize this plan? First, to check whether your optimized logical plan has been properly optimized or not. And there are some more things you can do. Generally, Spark developers don't do that unless you are too expert. But we'll cover in the, when we talk about the optimizers, we'll see, what are the optimizers run between the logical plan to the optimized logical plan. And some optimizers run and Spark run automatically, but Spark also gives you ability to have your extension where you can have, where you think you can optimize the graph with Spark DAG. If you think Spark lets you, inject your rules also while optimizing the Spark DAG. So we'll cover that in the optimizer session in detail. So these might be the reason if you want to see where you can optimize, you want to see what Spark has optimized, and over that, if you think you can optimize, then maybe you print and see to analyze. But mostly we look into the physical plan. So this is, when you say explain true, so it prints all types of plans. When you print explain code gen, so it will print your code which got generated, right? So your data, your Spark job, this data frame is generating some code internally, right? We saw the logical plan, optimized logical plan, and then physical plan, and then after physical plan, it generates the code. So if you want to see that code, you can see this. Then you can see last one is the formatted. So if you want to the formatted output, so you can see format, you can pass this df.explain and say pass formatted. This is how your output gets printed, and then it has 1 2 3 4 5. So that's how if you want to see same output, physical plan output in the formatted way, this is the way you do it. Now we'll focus ourselves on the physical plan, and we'll go over the mostly used operators. When we when we go to the Spark UI, some of the operators I might cover there as well, but for timing, let's focus on what we have. So mostly used operators are exchange. You are seeing this exchange. Exchange means shuffle. So you're seeing this exchange a lot. FileScan, once you read a file, so once you read Parquet file or ORC file or whatever CSV file, then you'll see FileScan. In the example which I have shown, I'm not reading a file because I'm in this example which I was showing you here, I'm not reading a file. I'm just creating data set on some range of numbers. So you will not see FileScan in this, but if you read a file, you will see FileScan, and I will show you in the when we go to the Spark UI, FileScan, I will show you at that time. Then you will have this hash sort or object hash aggregates. I think you see hash aggregate here, another hash aggregate here. So sometimes you will see sort hash aggregate, and sometimes you'll see object hash aggregate. What are those? You will see sort merge join. So that sort merge join appears here. Broadcast join is not appearing here, I think, but broadcast join you all know, right? When you broadcast a variable and on the basis of you join, that's a broadcast hash join, and that will appear in this plan as broadcast hash join. We'll cover this in the Spark UI session. So each rectangle on the Spark UI for the job retail represents one of these operators. So these are mostly used operators. If you understand these operators, I think you get sense of a grip on how to read a Spark plan, Spark data frame plan. So there's a question. Yeah. So we read the plan from bottom to up. Yes. You start reading the plan from bottom because that's where from it executes, and then you go all the way up. So that was right. So we'll read the physical plans of FileScan. Although the FileScan is not here, in the example which I've gone, but if you had FileScan, then how it will look like, and we'll see the same examples when we go to the Spark UI. So first of all, it shows you that you are reading a Parquet file, and there are a few things you will see. Right? I told you there's a pushed filters. Pushed filters. It's there's a this is some plan, and in that data frame got created where the profile ID is not null. So it pushed the not null condition while reading itself. So it will not read the records which have this profile ID is null. So this is good. This is what you want. So this push filter, if the file was saved with sorting on column part of filter, then this will be used. So if you are sorted this and then you are using, if you save the data set or save the record based upon you sorted on some column, and then you are reading that data set back and using that column on which sorting is done, then generally this is used. Partition filters. Partition filter is this. see, you can partition your record. So I will tell little bit. I think we covered a lot of content on partitioning, but let's say what we covered was partitioning in the Spark layer. The data is the memory. So let's say you're saving the data in the Parquet file or ORC file. It resides on the disk. Now you're reading that, and you have partitioned that record. While saving the record into the disk, you partition it. For example, if you have saved the record in Parquet and in Hive, then you are giving partition by year and month. So they will create a folder called year, and under that folder, if you have if you are partitioning on multiple columns year and month, so under 1 year it will create folder subfolders for month also. So that's how it saves. Now based upon how you are reading it, so it can do the partition pruning, which means it will not even touch some partitions. For example, I am giving this month is not null and month is equal to 5, so it's May month and it should not be null or something. So it will go to the partitions which has month has 5. It will go to that folder which has month is 5. So it will skip all other partition, which increases your performance. So this is how you can check. You have partitioned the data and you want to make sure your data frame is ready, and you're given that partition column in your where clause or in the filter clause in your data frame, and you want to see whether where the Spark is going only to that folder, only to that partition, and not touching any other partition, because that's what you want. So in that case, you check its partition filters. So it will do partition pruning, which means it will prune all the partitions which are not needed. It will read only the partition which is needed, which you have given. Data filters show the filtering done by Spark after reading the records. So where is the data filter? Yes. So after reading the records, some condition check will happen here. Profile ID is equal to this or whatever. So this is after reading. Selected bucket counts. So I think if I remember in the first session we have read, you can save this data frame in the bucketed format also. So this is save as table or something. So if you're saved in that, then it will read the how many buckets it had read. So it had read only 1 buckets out of 20 here. The partitions, how many it had? So it will come here somewhere partition counts. Do you see partition here? So it has read only 1 partition, which is good because it read only the month of May partitions. If it is not doing if there are multiple partition which satisfy some filter condition, you have given some filter condition which will end up Spark going to the multiple partitions, then you will see partition count more than 1 here. Okay. So that's about the physical plan. Now we'll cover exchange. I will spend 5 minutes. I think we are way over the time. So I will spend 5 minutes for this exchange, and then see we want to cover more on this or not. So exchange is the shuffle. Exchange means data is getting moved from some set of nodes to other set of nodes, and there are various ways shuffle can happen. There's various reasons shuffle can happen. So one is hash partitioning. So hash partition, you say in the plan here, right? So there was a hash partition somewhere to hash partition, exchange hash partitioning. So if you have this hash partitioning causes a shuffle, and hash partitioning happened because of these functions. Either you group by, or use distinct, or you join, or you do repartition only by key, or you say window.partition by key. I think this is mostly coming from Spark streaming. So then you have this hash partitioner. Another one is single partition, and you can see this when you go to the Spark UI. So here in the plan also you can see this is hash partitioning. On the UI also you should be able to see that exchange is happening because of hash partitioning or any other partitioning. So now another cause of shuffle is single partition. Single partition is when all data goes to one partition. You are not providing any column in the partition by, for example. So you are giving one example is window.partition by. There's no column or nothing. All data goes into one partition. So that's why you see single partitions there. Round robin, when no column is specified in the repartition. So for example, you say repartition dot column and say 10. So just round robin. Exchange will happen, but beside exchange, you will see round robin partitioning. And you could see that here, right? So exchange, round robin partitioning, and 9, I think it ended up creating 9 partitions. The range partitioning, I was supposed to cover range. I think we have to postpone to the next week. So when you use the range partitioner, at that time, range partitioning occurs, or use order by. So in both cases, range partitioning occurs. and you should be able to see on the Spark UI that this is range partitioner on this and this, all these things happened, right? So here user ID is, some user ID was selected in ascending order, that triggered the range partition, or you specifically use range partitioner. Now we'll go into the hash aggregate. So you saw hash aggregate here. So some aggregates had happened. So that was one, this is another. So wherever hash aggregate you see, so it depends data aggregation. So logical plan, so I decided there's a logical plan and then there's a logical optimize and then physical plan and all sorts of things. In the logical plans, you will see some aggregates needs to happen. It will not tell you which aggregate. Physical planning decides which aggregate, whether it's a hash aggregate or sort aggregate or object. So basically what it is doing. So when you aggregate, let's say you're doing, average, or you're doing sum, let's say you're doing sum by key or average by key or something, right? So if you do any of these operations, then based upon that key, it has to, get data for that key into one partition and then do the aggregation about that. So because it has to get data for the same key into one partition, so shuffle will happen. So exchange will happen. You will see that exchange in the plan, and you see the reason why this causes one of these three: hash, sort, or object hash. So generally it comes in pair. For example, if you see partial aggregation before shuffle and then after shuffle, what this means is that some combiner or some, let's say you are aggregate, you are doing the aggregation which is sum by some key, and your key is city. So data for city, for let's say for one particular city is in partition 1, partition 2, and partition 3 also initially. So Chennai appears, let's say for Chennai, partition has 3 records, partition 2 has 100 records, partition 3 has 10,000 records, and you're doing sum. So you'll see the Spark is smart enough to sum those for the same city on the same partition first, and then when it has summed those up, then the sum data will be shuffled to make sure that all data for the same city comes to the same partition, and then again sum will be applied over that to give you the correct output. I have given one example. So this I copied first from the Spark book. It's very famous Spark book on the internet. I think I copied pasted from here, but the syntax here is wrong. So this is the syntax you should use. So spark.range10 group by column ID divided by 2 as group, and then aggregate some ID as sum, right? This syntax you used, and then you explain it. So q.explain, this is what you will see. So some hash partitioning happening because it's getting hash over that. And same was the example in our case also, the butter plan I showed you. So these are the things which cause the the hash aggregates. And you could see here, right? Here. So there's a hash aggregate. So this partial which is happening, and then after that shuffle is happening, and after that full sum of this is happening, correct? So I have a diagram also after this. So this is a hash aggregate, right? This is aggregate. And the Spark UI, you can see the hash aggregate. Hash aggregate, you will see most of the time you will see one before exchange and one after exchange. This exchange represents shuffle. And if you see, these are the functions which cause it: group by, distinct, or drop duplicates. These cause this hash aggregates to happen. The logical plan will only tell this is an aggregate. But during the physical planning phase, the physical plan will decide whether it's hash aggregate or sort aggregate or object hash aggregate. So here, this is a partial sum, as you could see, and then exchange happened, and that's the final merge sum. So that's how the aggregate works. We covered only the hash aggregate. Now we'll talk about sort aggregate. Sort aggregate represents joining two data frames. Basically, when you're joining two data frames. So often exchange and sort before joining. So this is an example. So there are two data frames which you want to join. Some shuffle happens, then some sort happens on both of these, and then some joining happens. This is the example taken from the Spark UI. This is Spark UI. I will show you the Spark UI also eventually. So often there is one exception to this. So it often exchange and sort before joining. This is one exception. We'll talk about exception later. So it will always have branches which merge in the sort merge join, which is this. One branch is exchange and sort. Some data sets have been moved while joining, right? Let's say joining based on the city. So one data frame city data is spread over all of nodes. Other data frame city data is also spread all over the nodes. So exchange happens. Then some sort of sorting happens. And then you join those two cities. Sorting on the basis of city is happening. Then you join those. So that's what sort merge join is. Broadcast join, I think we'll stop it here. Broadcast join is the last one. So data is broadcasted. The broadcast exchange operator you will see in the plan. This data is on the each executor. Broadcast join data is joined with other data sets. So when that happens, you will see broadcast hash join happening. So broadcast data, broadcast exchange is separate job in itself. So we'll come to that. I have not given an example of this, but I think you all understand at least this much. Now, this is where I stop.